Hi everyone, welcome to Pre-Calculus Lesson 3.3 Dividing Polynomials, Part 2, Synthetic Division. So this is the other method that you can use when you're dividing polynomials. And this is actually my preferred method because the math is much easier, but you can really only use it when you're dividing by a binomial. There is no coefficient on the x. So that's really the only time you're allowed to use it. So it's very limited in its uses, but it is much, much faster and easier than long division. So it has its positive values and its negative values. So let me show you the process. This number right here, I'm going to pull it out of there and change the sign. So it's positive 3, and I'm going to write it in a box over here. Now, the notation as far as boxes and lines does change based on the person. I like to put that number in a box. Then I'm going to write the leading coefficients, all of these coefficients. Okay, and again, if they missed a power, I'm going to put a 0 in there. And that's really, really important. Your polynomial has to be in standard form, and you must insert those zeros or your answer will be very wrong. Okay, really important. Put the zeros. Okay, so it's 2, then negative 7, then 0, then 5. Now here's what I do. Bring down the 2, then you multiply. 2 times 3 is 6, then you add. Negative 7 plus 6 is negative 1. Then negative 1 times 3 is negative 3. Then you add, and then you multiply. 3 times negative 3 is negative 9. Then you add. This last number is the remainder. And then this is going to have no x. This will have 1x, and this will have an x squared. So 2x squared minus 1x minus 3 with a remainder of negative 4. So I can write it as minus 4 over x minus 3, or I can do plus negative 4 if I wanted to, or I can even write it in that form that they gave in the last video, p of x equals d of x times q of x. I have an extra parenthesis, plus r of x. And you can write it like this. You would just do x minus 3 here. You would do your resulting quotient of 2x squared minus 1x minus 3, and then it would be plus the remainder of negative 4. And you could write it like that as well. Okay, so those are your options. I like this method the best with the fraction. It's easy to write. It gives you a lot of information about what you were dividing by, what the remainder was, and what this is. I think it's really easy to look at. This looks like just one big long polynomial that you almost want to multiply out and combine like terms and end up with this thing again. Okay, so it's your turn to try it. Pause the video, complete this question, x to the 4th minus 2x cubed plus 3x plus 1 divided by x minus 3. So do that division, press play, and see what I have for you next. Okay, the next thing I have for you is the remainder theorem. This is highly useful, especially when you have a polynomial that has a lot of high powers and you need to evaluate it for a number. So basically, if I wanted to evaluate this polynomial for 3, all I would do is do my synthetic division, and the remainder is the answer. That's why it's called the remainder theorem. So if I wanted to evaluate this, the remainder is the answer. The rest of this synthetic division does not matter at all. So let me show you the example. We have this thing that I'm evaluating for p of negative 2. Which is the same thing as dividing by x plus 2. Because notice you would take this, put it in the box, and then you'd write out these terms. So it's 3, 5, negative 4. Look, they skipped x squared. Be careful. Everybody misses that. That's where I see almost every mistake when people are doing division like this. Okay, now I'll draw my line, bring down the 3, multiply, add, multiply, add, multiply, add, multiply, add, multiply, and add. Okay, so my remainder is 5. So hypothetically, if I was just asked to divide, what I would do, this is my remainder, this is no x, x to the first, x to the second, x to the third, x to the fourth, and you just count up on the power starting from that side. So you get 3x to the fourth minus 1x to the third minus 2x squared plus 4x minus 1 plus 5 divided by x plus 2. Now, that is the answer for dividing, but if I wanted to just evaluate, my answer would just be what I had as a remainder. Do not ever circle any part of this as part of your answer for this. Always make sure that I see your answer in a circle, okay? Because if you just leave it as the synthetic division like this, I have no idea what you mean as your answer. Make sure you circle it, or at least put a big arrow next to it that says, this is the answer, okay? Make sure of that, highly important. So you're going to try one of these. It says, use the remainder theorem to evaluate p of 4, and here's my polynomial, x cubed minus 4x squared plus 3x minus 5. So pause the video, go ahead and do that, and then press play to see what I have for you next. Okay, so next I have the factor theorem. If I wanted to know if a binomial is a factor of a polynomial, what I could do is do my division. So hypothetically, if I wanted to know if x minus 3 was a factor of this polynomial, I would do my division. If the remainder is 0, then yes, it is a factor. If the remainder is not 0, then no, it's not a factor. Okay, and this is something that you do in Algebra 2, but you may not remember it. Okay, so in my factor theorem, I have this. Let p of x equals x cubed minus 7x plus 6. Show that p of 1 is 0. So again, I'm going to apply my remainder theorem. So I'm going to take that 1, put it in the box. Notice I'm not changing the sign when I put it in the box. That's really important. Now I'll do my synthetic division. I line up my 1. Notice they skipped x squared, so that's a 0. Negative 7 and 6. Bring down the first number. Multiply, add, multiply, add, multiply, add. Notice my remainder is 0. That means that x minus 1 is a factor of this. And guess what? This polynomial is going to be x squared plus 1x minus 6. Now, it says, and use this fact to factor p of x completely. So I did show that p of 1 is 0. This is my first factor. This is the rest of the factored form. I can factor this using just plain old factoring. So I say what multiplies to negative 6 and adds to positive 1. And I get x plus 3 and x minus 2. So my completely factored polynomial is this. And we're going to talk about factoring polynomials very soon. Okay, that's coming up later in our chapter. Now we have one last example on this video. I'm sorry it's been long, but this is it, the last one. It says find a polynomial of degree 4 that has these zeros. So what I'm going to do is I'm going to write those out as a factored form. Then I'm going to multiply everything together. Okay, this 0 would just be a plain x that shows up. Okay, this minus 3 would be x minus negative 3. Okay, that's done. This 1 would be x minus 1. And this 5 would be x minus 5. Okay, so all I'm going to do is multiply this out. Personally, I like to pair things up, so I'm going to do these two first. And I have x times x is x squared, and x times 3 is 3x. And then this I'm going to multiply out. I get x squared minus 6x and plus 5. I just did x times x x times negative 5, negative 1 times x, that combines to this negative 6, and negative 1 times negative 5. Okay, now I just need to multiply this out. So I'm going to do x squared times x squared is x to the 4th. X squared times negative 6 is negative 6x cubed. X squared times 5 is 5x squared. Now I'll do the 3x. 3x times x squared is 3x cubed. 3x times negative 6 is negative 18x squared. 3x times 5 is 15x. Notice how I lined up my like terms as I did that. This was from the first term multiplying in. This was from the second term. I lined up my like terms so it's easy to just add this all together. My polynomial of degree 4 is this. And this adds to negative 13x squared and plus 15x. That is my answer. Ta-da! That's it for this video. Please let me know if you have questions. Don't forget to do your classwork questions and turn them in at the end of the period.